Welcome to All Things Policy, a daily podcast supported by Pragati, a flagship media initiative of the Takshashila institution. We're a bunch of policy nerds based in Bengaluru, and we like to bring a fresh perspective to Indian affairs and an Indian perspective to global affairs. So grab a cup of coffee, sit back, and join us for today's chat.
Hello and welcome to yet another episode of All Things Policy, where we discuss policy issues of relevance. My name is Priyal de Almeida, and I have with me today my friend and colleague Arjun Gargeyas, who is also a research analyst at Takshashila. And what we are going to be talking about today is something that he had recently published as part of his research project, that is about AI hardware. And Arjun, welcome to this podcast.
Hi Priyal, good to see you here.
Yeah, same. Good to have you back. Considering that every time we get together, we mostly talk about tech. Today, we're covering another aspect of tech. So, Arjun, let's get started. Yeah. So, when we talk about AI hardware, what exactly is AI hardware? And can you give us a brief about like its capabilities and what are like the different types which are being developed and which are available in the market as of now?
Yeah, sure. The whole point of AI hardware is the fact that it combines both the ability and applications of both artificial intelligence and
Yeah.
semiconductor technology itself. So what exactly is it? Is we can get to know that from definition of AI. So AI is generally defined as the machine's ability to perform any sort of cognitive function that is associated with human mind, such as reasoning, learning,
Okay.
perceiving, and all that. Now, if
Right.
chip or any kind of hardware device can do the same
Yeah.
thing, that can mimic a human mind, or at least can
Right.
understand or how the human mind works and can respond to it in that way, then it
Right.
is basically that kind of hardware is something called as AI hardware. So AI hardware is just the fact that it is integrating both the AI and the semiconductor part of it. So in
Okay.
essence, that's the basic, definition of AI hardware itself. So if you
Right.
talk about the types and the kind of how do you kind of classify AI hardware, then I think it all comes down to basic two AI algorithms itself which exist. So like there are two basic activities that enable any sort of AI application. That is nothing but training and
Okay.
inference. And based on these two activities or these two phases, you can also classify certain hardware and certain devices on the concept of training and inference itself. Now, what is training? What is
Okay.
inference? Let's kind of get into that. So, training is when you kind of
Right.
use your device or your chip or your hardware to kind of use massive amounts of data and multiple cycles of going through this data,
Mm-hmm.
and the fact that you kind in the end you kind of develop a feedback loop to improve efficiency. So you feed in massive amounts of data in terms of images, in terms of videos, in terms of audio files, whatever. It doesn't matter what it is, and you kind of train the system or train the
Right.
hardware itself to understand what is what. So if you want the hardware to
Okay.
recognize dog, let's say, so you feed like 1,000 images of different animals, out of which around
Hmm.
50 of them are dogs. So once you
Right.
feed that into that time, you kind of develop an efficient method for or you train the device to understand what a dog is. So
Okay.
that is how
Okay.
you can understand what exactly. That's how you train the hardware essentially. That is nothing but the
Okay.
training AI hardware. So in terms of inferencing, these algorithms are already trained, and now the
Hmm.
algorithms have to respond faster and not store more data. So what happens is
Okay.
you've already trained the device. Now, as the data comes in, it has to be crunched and it has to handle that small set of data only once. So
Okay.
it has it has to be run at like wherever it is deployed, and as soon as any kind of data comes in, it will just figure out what it is, what exactly should it do, and kind of gives
Hmm.
you the output. So it, yeah,
Okay.
in terms of those two major activities itself, then you can classify the hardware in terms of whether it's either training hardware or if it's an inference hardware. Or
Right.
yeah, it's just those two major activities wise. And if you can understand the difference in not just the how it works, but also the fact that what is the cost involved. If the training hardware requires a lot of heavy duty hardware because of the fact that it has to iterate the same data multiple amounts of times, and the fact that it is
Okay.
deployed in multiple phases. And
Right.
when it comes to inferencing, it's cheaper and it's more easily available compared to training hardware because you need specific softwares and code, or at least programming languages
Right.
itself, to uh, mm, efficiently train AI algorithms, and you don't need that
Okay.
for inference. So that is the major difference in terms of like the activities type. And the other three major types of AI hardware based on the type of application itself is that I don't know if people who have been in the industry have, but I'm pretty sure like people who have worked in the semiconductor industry would know these. It's basically what we call as FPGAs, that's the speed programmable gate array, and one is
Okay.
the graphic processing unit, that's the GPU, which is generally
Right.
used to. It was initially designed for graphics. Now it's used for a lot of computationally intensive applications like data mining, cryptocurrency mining, and stuff like that. And
Right.
what we
Okay.
call as application specific integrated circuits. So these are custom made, which are optimized for that particular application itself, and it is only going to work for that application and nothing else. So these are the three main types of AI hardware, which are on the basis of applications itself. So on the basis of
Okay.
activity, it can be either training and inference, and based on application, it can be either FPGAs, GPUs, or ASICs. And these are the broad, classification of what we call as AI hardware itself right now. And again, it's not just
Right.
exhaustive list, but there are many more, and you can put most of it into these buckets.
Okay. That's actually nice overview of like everything that, because I think as a person who
Mhm.
does not know anything a lot about tech and stuff, so this is a nice overview. So I think in your document also you had mentioned that, India might need to focus on building the AI hardware ecosystem. So why exactly do you think we need to do that?
Yeah, so one of the main reasons why we wanted to focus on this aspect or on this field itself was the fact that there was global AI hardware landscape which is developing, and India can tap
Okay.
into it. Now you know that there has
Right.
been a rise in AI applications, and like
Right.
from virtual assistants in our homes to facial recognition programs which can track criminals, whatever. All these require
Right.
hardware which needs to work at the back end for these
Yeah.
AI algorithms to actually run. So now that we know that there needs to be like hardware which is includes storage, memory, logic, networking, all that. So this kind of next generation hardware architecture is being developed by semiconductor companies to increase
Okay.
both the computational efficiency and to help handle this large data set to different memories and storage. So specialized
Okay.
AI hardware can be better suited to handling like vast amounts of data that any kind of AI
Okay.
application might require. And
Okay.
as per estimates by McKinsey, AI could allow semiconductor companies to capture around 50% of the total value of the market. And this AI related semiconductors or hardware can, yeah, by 2025, it could account to almost 20 to 25% of all the demand, which can be around like $70 billion in revenue. So
Right.
that is like an economic significance itself. And
Okay.
specifically why AI hardware policy for India and why they need to focus on it is mainly three main factors. One is the fact that there has been a gradual shift towards application specific hardware. So instead of general purpose
Right.
hardware which can do this, can do that, which can, kind of do everything, now there has been repeatedly calls of manufacturing specific hardware itself, which is
Okay.
application specific, and it can um, target certain kind of applications. And now in critical sectors such as space, defense, telecommunications, and all, custom hardware with this kind of AI capabilities are being developed. So you need kind of application specific hardware to tackle very niche areas of or very niche sectors which might require
Okay.
better computational capacity. And
Right.
also the fact that if India decides to put its efforts into this ecosystem, they have the ability to focus on inference chips itself. So as I said, right, there is a cost difference between training and inference chips, or
Right.
whatever inference hardware. The fact that you need specialized code, specialized programming languages only for training, but inference chips can be developed on a more cheaper level. It's more easily
Right.
available and all that. So
And I
regarding the
think
cost
when it
benefit
comes
ratios,
to tech, like
Indian
human
semiconductor,
resources, yeah, sorry for
yeah.
cutting you off, like, but I think even in terms of like human resources and stuff, we have that capabilities, right? It's not like we are far behind
Mhm.
any other country in that matter.
Yeah, so that's exactly the one of the main reasons, right? So regarding any
Right.
kind, if you take the cost benefit ratio, like the Indian semiconductor manufacturing dream as we have it now can benefit by investing in AI inference chips and the fabrication of these chips rather than every other thing which we want to do, because it's easier
Right.
to develop, it's cheaper, you don't need very skilled labor to do it, and all that
Yeah.
comparatively compared to like a normal fabrication center itself. And yeah, that
Right.
is one of the major things. And also the fact that traditional chip architecture, which was dominated by few companies like and other major companies itself, are now kind of moving like across, and like there has been a transition in architecture wise. So how I have to put it in a very simple way then is the fact that there have been other architectures which have been coming up which have smaller and lesser complex set of instructions, which is more on a software side. So
Right.
there is more space left on this architecture for adding AI capabilities. So to have AI hardware itself, these newer processor architectures are better than the older ones. So AI hardware
Okay.
is being developed due to the fact that there has been this rise in alternatives to kind of normal processor architecture. And one of the main reasons that there has been that is the fact that easier to integrate AI algorithms onto newer processor architecture than the older one. So yeah, those are like the main reasons why India should focus on this area as a potential policy priority field, because it's just the fact that the entire global trend points to the fact that this area would be a majorly economically significant and strategically dependent area in the future.
Right. That's actually very interesting to know because the fact that we already have what it needs to build this ecosystem into a much stronger direction is actually something that we can build upon and keep moving ahead. Now, Arjun, I have more questions to ask, but before we actually move on there, let's take a short break and we will be right back to continue this conversation forward. Hello and welcome back to this episode of All Things Policy. So, Arjun was talking to me regarding the AI hardware and its capable. So, previously, before we went on a break, we spoke about what exactly AI hardware is, its capabilities, and why exactly India requires this ecosystem, as well as where do we need to focus on to build this ecosystem further. Now, Arjun, you mentioned in the previous, during our conversation earlier, that, if we focus on this, obviously it will prove us beneficial in the on the economic front, etc. Right? Now, keeping that in mind, what are the strengths and opportunities that India has in this domain that can be sort of utilized to start building this ecosystem?
Yeah, so if we take both the strengths and opportunities, we can kind of divide them into both the semiconductor perspective and the AI perspective itself. So from the
Right,
semiconductor perspective, if you look at the strength, then yeah, one is the fact that we have such a thriving design workforce. We have like a majority of our electronics engineers work in semiconductor design. They are exposed to all the design cycles, and majority of the world's semiconductor firms have their design houses in India. And
right,
also the fact that there is easy access to AI hardware models because there are already available open source parallel computing platforms and APIs to build AI applications on semiconductor chips. So it's not
okay,
the fact that there is the licensing issue does not come into the picture because there has been, I mean, there is that availability to these AI hardware models. And also the fact that the government priorities itself are focusing a lot on semiconductor manufacturing and design, especially with the 76,000 crores package last year. And there is both the design linked
right,
incentives and the manufacturing incentives which are being provided to firms who are engaging in any sort of semiconductor manufacturing and design. So in that way, that's these like are the strengths from the semiconductor side. From like the AI perspective,
right,
I think there has been a rise in homegrown IP, intellectual property for AI itself. India currently ranks eighth in the world for AI-related patents from during the period 2000 to 2020, first 2 decades of
right,
the 21st century, and it has over 1037 AI patent families. And the fact that there has been a slow and steady rise in the development of these indigenous or domestic AI applications, with almost 15% of all the Indian patents and IP are related to kind of AI applications compared to the worldwide average of around like 10% ish. So we are
right,
developing more and more AI applications on our own, which can be kind of deployed on these kind of hardware. And as you had mentioned, there is a lot of availability of labor and human capital. There is a huge talent supply in the form of engineers. Every year, there is AI research which takes place at both academic and non-academic institutions. And the fact that under
right,
the innovation mission by the government also aims to cultivate researchers in the field of AI, scientists, researchers, and um, people who are competent enough to work in this field for the future. So those are
right,
like the major strengths itself. And now, if you have to look at the opportunities, there is comparatively better benefits of AI hardware than normal, chips itself.
right,
Specialized memory for this AI hardware is almost 4.5 times the bandwidth compared to traditional chips. And this increases efficiency, storage, and it can help in like specialized sectors such as military and space. So that is one thing. And one of the major things is that trailing edge nodes are actually satisfactory for developing and manufacturing AI inference chips. China itself manufactures AI hardware with almost 55 nanometer technology to 40 nanometer technology, which is kind of a low
okay,
hanging fruit for India to set up its own commercial fabrication facility. You don't have to invest too much start of manufacturing and production, unlike, like 7 nanometers or 10 nanometers, which is very, very, very costly to kind of start production. And it requires significant amount of investment. So that's one thing. And the fact that AI has the root create Indian specific applications itself. Now we can see that this AI hardware can be used for natural language processing. Considering the linguistic diversity of India, it can be used for like it can be used to bridge the communication gap and encourage translations between regional languages and remove all these kind of barriers. In network security, it can provide security and protection by predicting cybersecurity threats. In computer vision, it can develop these computer vision models that automate tasks like the human brain. It is a significant factor in the transportation sector itself, such as estimating, tracking traffic, road condition monitoring, pedestrian safety, and all that stuff. So AI has a lot of opportunities there in creating specific applications for India itself, because there India has certain other demands compared to the other Western countries itself, and AI can bridge that gap. And finally, is the fact that AI has the possibility of creating solutions for major critical sectors such as healthcare, manufacturing, agriculture,
Hmm.
military and defense. And these are just some of the areas where AI can make a mark. And India would clearly, I mean, this is an opportunity that India would not want to miss, considering the fact that it can streamline the processes which currently exist. You need lesser manpower itself. You don't need too much investment and all that. So you can let the software and you can let the tech handle the large scale implementation processes in these kind of areas. So yeah, in terms of all this, that there is a lot of opportunity for AI to kind of create policy solutions in critical sectors. And yeah, that is why AI hardware needs that kind of a push right now.
Right. Interesting. Also, if I'm not wrong, I think this sort of a document where you sort of analyze the strength and the weaknesses and the opportunities, threats, and etc., specifically about like AI hardware in itself, is like the first time it's this kind of document has come out from our country, right? You're the first person to do it.
Yeah, I mean, the fact that AI hardware itself has not been delved into a lot, and
Yeah.
it's just an overlooked sector in terms of the fact that it's just another normal chip to look at, but
Right.
it has the ability of utilizing AI algorithms, which you won't know until you kind of actually understand how the entire hardware works. So that
Right.
I'm guessing that is one of the reasons, but yeah.
Yeah, that's actually interesting because obviously, since it's been overlooked in so largely, it's good that, like, you're sort of like bringing that attention here and showing what can be done with this and what are the opportunities that India has on this side, right? But actually, Arjun, given that you're a policy analyst and our job mainly is to give our policy recommendations. So let's say tomorrow, if the government decides to include the AI hardware as a policy priority area, what are the some
Mhm.
recommendations that you think, as a policy analyst, that the government should look at to make a mark in this field?
Yeah, so I think three or four major areas. One is the fact that you can have a trailing edge fabrication facility or a manufacturing center only catering for inference chip production. Now, we know that
Right.
trailing edges require less investment, can be set up faster to start production. And as I said, because it's sufficient enough for this production of inference chips, 45 plus nanometer fab in the country can be used for the large scale production of AI inference chips. And this can be a public private partnership which is dedicated to handling this AI hardware production.
Okay.
So the government has already come out with a scheme for setting up hubs in the country, and this can be included as part of that and can provide the financial incentive which has already been promised under the existing scheme. So
Right.
that's one. And then I guess the second one would be to fund and support open source projects related to AI hardware design. As I said, training chips are very hard to manufacture and design because they have a lot of dependencies and they require licensed software, code, and all that stuff to
Right.
design this hardware. Now, there have been open source alternatives such as OpenAI's Triton language has been deemed a credible alternative to NVIDIA. CUDA, the US Department of Defense, DARPA, has also developed thing called real-time machine learning to develop chips that are majorly tailored towards running this AI operations. And recently, IASC came out with what is called as the Aryabhat one. It's a kind of a chip which is helpful for AI-based
Okay.
application and that require a massive amounts of parallel computing operation. If the government should make it a priority to fund, support these kind of projects, which can help them, get out of the whole concept of licensing fees and all that when they have to kind of start designing AI hardware itself. So if you can use these open source projects, then it'll be a good thing. And finally, I guess it should be the whole concept of international cooperation because this is a field which India has done little in. So you need kind of technological cooperation. And I'm not saying international cooperations with everyone. I'm specifically talking about the US in this case because the US have the monopoly over AI training hardware because most of the firms which have done that are from the US itself.
Right.
And the recent
Okay.
sanctions by the US government has also prevented exports to China of AI hardware because they feel that they might be used for military purposes and stuff like that. So India cannot afford to get on the wrong side of this, and they have to cooperate with the US and its other allies such as the Quad and the Five Eyes and all that. So you can cooperate with them considering multilateralism is essential in this kind of field and India can play a specific role in the specific part of the supply chain and take the help of other techno-democratic powers to make a mark and just
Right.
get into the space itself. So yeah, I mean those are at least the three major ones. But yeah,
Cool.
as the government decides to move into the field, then there might be other areas which might require focus and investment and whatnot. So at least for now,
Right.
I guess this is something that they might want to focus on.
Yeah. Cool. That's great. Thank you so much, Arjun. Thank you for joining me at this podcast and giving us like all the information that you have about the AI hardware ecosystem. And I hope our listeners had a fun time listening to us having this conversation as well and they got something out of it. So,
Yeah,
thank you.
sure. Thank you so much, Priyal. Yeah.
Yeah, thank you for being here. So, yeah, for our listeners, do continue listening to our new episodes that will keep coming up. And thank you. I hope you enjoyed this one. Bye bye.
If you liked our show, don't forget to check out other interesting podcasts on the IVM network. You can tune into them on the IVM Podcast app, ivmpodcast.com, or wherever you listen to your podcasts. You can also follow IVM on social media. The handle is at IVM Podcasts on Twitter, Facebook, and Instagram. And hey, if you'd like to dive into Takstashila's research on technology, strategy, and economic affairs, check us out at our Twitter handle at Takshashila INST or our website takshashila.org.in.